Hello, everyone. We got quite a few questions regarding how this generative part works. And I realized that it would be too hard to make an article or any written text. It will be too boring, basically like a wall of text, and no one would ever read it. So we decided to make a hopefully short walkthrough on how the algorithm work. It will be a bit nerdy, but that's what it is. It's a mix of coding and design. So, but I'll try to make it as easy to understand from someone not from VFX or generative background as possible. So let's dive in. How the whole thing organized? You probably already see like what the hell is that? So the software I use for generate all the crystals called Houdini, made by a company called Side Effects. Initially, it was used mostly for visual effects in Hollywood movies. And if you ever seen explosion or a bridge collapsing or something like that, chances are pretty high it was made in this software. But over the years, they add some tools, and now it's quite popular among game devs for content, like for procedural content creation and for generative art or motion design. So I'm from VFX and motion design background, but I have my first degree in computer science, so I try to mix both sides in my projects, both coding and the design part. So that thing that usually people refer as a map of London subway or something, because I understand it looks something like that. It's actually a node graph, how they call it. It consists of some blocks called nodes, which usually data source or data processor or output. And these beautiful lines connecting them, it's actually just a flow of data. So when you try to like understand what's going on here, uh, this is a end result, and you go backwards through this tree and check like what's going on, how this data flows. And in our particular case, everything starts over here. This is a node which takes the data taken from and parsed from blockchain and creates some parameters for our algorithm to run on. So after this thing works, it generates these attributes. You probably have seen it already on our website. So balance of Ethereum, you have balance on NFT, change of these balances over time, these friendly collections we support. For now, we announced only XOIDs, but the list obviously will be bigger than just one. Uh, ID of the block when the transaction happened, ID of the wallet, who is the buyer, and timestamp and transaction number in this wallet. And you see, we have 7 transactions right now. So that's why I have this complex crystal over here, because it's like fully formed over 7 steps. It obviously will, after minting, will start from just one. Anyway, so after that, after I get all this data, this is probably the most interesting part for you, where all the traits are generated and where all the magic happens, like trait-wise, how, like, where you get this very specific rare crystal or not. And unfortunately, right now, I cannot show you what's inside this black box. I will make probably another video and make this algorithm public after the growth will happen. But for now, I think it would like ruin all the experience if you can tell for sure from the very beginning what you are going to get. So this part will remain mystery for now. Uh, And over here, I'm overriding for a simplicity purpose. So we have different types of crystals, obviously, not just one. But for this demo purpose, I restricted it to just one. So all the crystals are from the same group of them of algorithms. And what happens after that? So I'll give you like a brief explanation, and then we'll dive inside and see some like in-depth details. So at this point, we have all the data prepared, traits generated, and the system knows exactly what it has to create. This part deals with actual creation. So after it finished, you have something like that. So all the crystals are generated, and yeah, as you can see over here, all 7 of them. After that, I have to orient this thing because the problem is with every single additional crystal, we have to find the best camera angle so you will actually see what you got, and hopefully this additional part don't intersect with others, so it tries like this blocked, and it's like have some additional pieces inside it, but what it does, it tries to rotate the camera so you have the best angle. And just to test that, I can show you how it goes. So it starts from the just one, and then the second part is generated, and then new one. So it add pieces one by one and try to like rotate the whole thing so you have the best view on it. After that, this long part, it's all about colors and shading. I will not touch materials in this introduction because it's a like theme of its own. It's a complex topic. I probably will create another one at some point. And after that, you basically have your geometry and colors and a lot of additional attributes assigned to each one. So if you check, I have like a lot going on over here because I use this data for shading, because obviously it should be like more complex and more interesting than just a flat color. So like bump maps, color mixing, additional textures, how displacement work, all this stuff happens on the shading. And eventually I probably will create another demo video explaining how the shading works over here. But for now, that's what we get from the algorithm, the geometry. Let me dive inside and show you how like one branch, because for today we focus on one type because we have many different types of crystals, right? Like families of crystals. For now, I restricted it to just one type, what I call like quartz-like. It's obviously not a scientific name for this crystal formation, but it was easier for me to tell them apart. So this one, so I just keep a single one for now. Let it, yeah, generate uh, something like that. And how this thing was created. First of all, we create the base. It starts from very simple sphere, and then based again on the properties of your wallet, it's slightly deformed, so it will get a shape, something like that, and it will be different for every single crystal. Otherwise, it will be just like perfectly circular formation. It's not good, look interesting and good enough. And we divide this into 7 basically segments, and each one is used as a gross starting point for these beautiful crystals you just seen. So for now, it takes just one piece and decides where, show you this part. So this is the surface of this piece, and crystal should start growing from somewhere here, right? And the algorithm itself is, well, again, it might look quite complex, but if you go step by step, it's not very difficult to follow, I hope. So what does it take? It has this base shape, basically surface, right? And the direction from where it starts to grow, something like that. And after that, I find placement positions for all the crystals I will have there. So basically points on the surface with the directions, a lot of randomization over here based again on all the attributes you have, all the properties. I will not dive too deep in this, but this distribution and the scale of the crystals and amount of them, it's all based on parameters from your wallet. And so I create the placement and I create what I want to place there. Basically, for this particular case, it's just a prism, and it just does like that. It just copies them there according to the scales and directions. So I have this base formation. Some crystals, as you can see, are broken a bit after that. So this what I call like perfectly shaped ones. I have additional group which more or less works the same way. So I create additional points, and but these are broken more than group on the right. So you see like the difference. These are more like perfectly shaped, and over here you see this has a more complex shape. So combined, we have these, but the problem is it doesn't look good on the surface on its own. So we need additional elements over here. And what I create, let me see, is it? Yeah, so some additional elements around these crystals. So just smaller pieces to make the shape look more complex and basically just more interesting. So combined, they form something like that. And that's our output. So that's where you have quartz like crystal and combined together. So we seen just one, but if we go through all 7 iterations, basically it creates this beautiful and complex shape. It has to calculate it for a bit even on my pretty fast workstation because it takes time. But yeah, that's the shape. And after orientation, assigning colors, assigning materials, and assigning all of that, we end up having something like that. And the last step remain is just to render the scene. I obviously don't do this manually because on a 10,000 crystals it would take a ridiculous amount of time. So the scene, when it's open on a render farm, it knows where they take this data from, and it's already prepared. So the scene starts, grabs the data for particular iteration of particular crystal, renders it, put it on our server, and we push it back to OpenSea, where the only thing you have to do is refresh the metadata. It takes some time because the queue is depends on how many sales we have per, I don't know, per minute, per hour, whatever. But yeah, eventually the whole queue goes through. It's all got rendered and everything got pushed back to OpenSea. And you just for you, it just like you press buy button and wait a bit, and after a certain amount of minutes, the crystal magically grew, and you have a new version. So I hope it clarifies a bit the complexity. And as I said, it was just one type of the crystals. I have like 7 or 9 already. Each of them have a different algorithm, because some are more organic, some like fractal-like, some specific for a specific collection. So they're different, and there are a lot of Python and VEX code and this I don't know, nodes It looks like spaghetti to me, but that's what it is. That's what I have to deal to create something beautiful for you guys. So see you on the next demo video. I hope I will have time before the lunch. If not, I will have it after the lunch because obviously we are crazy busy in these days and it's hard for me to find the time for create videos like that. But I hope I will find a time to like walk you through all additional steps we have to go from this to what you see in sneak peeks in Discord. That's it for today. Bye.